So now we're going to take a look at how we can use our radians, and we're going to spend a bit of time investigating arc lengths and areas. So if we're trying to find the arc length and we know the angle of our sector in degrees, we know the radius, we'd start by thinking, well, I know what the circumference of a circle is. The circumference is equal to 2 pi r. That would be for a whole circle. If I know that I've got some angle for this sector, it means I've got a portion of that circle. So what proportion of the circle is this sector? Well, it is, the easiest way to think about it is that we've got theta degrees out of the whole circle. That's the proportion it is. So if I want to find the arc length, I would say I've got theta degrees of the circle. That's what proportion I've got of my whole circumference. So that's how I'd find my arc length working in degrees. Let's look at that whole idea now if we're working in radians. Obviously, the circumference of the circle stays the same. The circle doesn't change size just by the fact that we're measuring our angle with radians. So we're still going to have the same circumference. Rather than thinking of our angle as out of 360 degrees now, we're going to think of our angle out of 2 pi radians, because that is our whole circle. Remember back to that wheel we were filling out, we said, so we got to our whole circle, we had rotated 2 pi radians. So this is degrees, let's write that up here, degrees, and we're going to have radians now. Okay, so arc length this time, we've got theta radians out of a whole circle, out of 2 pi radians. That's the proportion of the circumference we've got. And you'll notice that this will simplify quite nicely. We've got 2 pi and 2 pi, so this will actually simplify to r theta, or theta r. I think typically we'd write it as r theta. So much simpler formula that we can use. We can look at the same if we're thinking about the area of the sector. So let's do the same again quickly. I'm going to get rid of this now. So if I wanted to find the area of a circle, we know that the area of a circle is pi r squared, pi times the radius squared. If we're working in degrees, we'd say it's theta degrees out of 360 is the proportion of the circle we're dealing with. We'd multiply that by pi r squared. So what about with radians? So we're going to find the area of this sector. So I've got theta radians out of 2 pi radians. That's the proportion of the circle that I'm dealing with. So I'm going to multiply that by the area of the whole circle. Once again, we're going to simplify this down a little bit. So we're going to have pi's are going to cancel basically. So we've got half r squared theta. Okay, that's our area of a sector. Obviously, you can only use this version of the formula if your angle is in radians. Similar to our arc length formula. You use r theta if your angle is in radians. If it's in degrees, r theta is not going to work. You're going to have to go back to this. Okay, so you've got a couple of formulas to use. Make sure you're picking the right one based on the measures that you have. There are a couple of questions to attempt on page 14. If you go into It's Learning, you will find my solutions to those.